Hello and welcome back. So the first step to create our first cognitive search index is to get our source ready. In this case, we are going to create a Cosmos DB collection and upload our property data. So in my Azure portal, I'm back to my resource group, and under my resource group, I'm going to choose my Cosmos DB account and I'm going to create a new container. So go to Data Explorer, to our TGG database, and in there I'm going to just create a new container with the name property, and I'm going to put partition key as my local area in our dataset. So if I go back to my dataset, you can see under fields we have geolocal area, which is same for one area. For example, for downtown, this value will be downtown for all the 2000 entries. So I'm going to pick this. So here I'm going to choose fields slash geolocal area as my partition key. Now Cosmos DB distributes your data internally through various physical partitions using partition key. So it always makes sense to have partition key as a subset of your whole collection data. Now partition key ideally should not be too distributed or too less distributed. What I mean to say is, let's say if you have a global database with data from different countries and cities, so it makes more sense to have partition key something like city or country so that it's well distributed across physical partitions. But let's say if your data has a different ID for each item in your collection, then making that ID as partition key will not make much sense because each item will have its own partition. So in this case, we have our Vancouver city's data with various geolocal areas. So it makes sense to have geolocal area as our partition key. Now I'm going to set my throughput as 400. We can always increase and decrease it as required when we use our collection to upload and query our data. But for now, this is good enough. Let's create the container. Now, once the container is ready, just go to items and click on upload item. Here, I'm going to just upload the 3 files that we downloaded one by one. This is the first one. Now you can also see the logs here, and a lot of uploads are getting throttled, you can see. So for this upload to be quick, you can go to settings and increase your throughput a little bit. I'm going to increase it to 1000. You can also see the monthly cost that it will incur, even the hourly cost. So this is going to be quick, so we'll probably spend under $1 to upload all our data. And once that is done, I can go back to 400 as my RU. So now you can see not a lot of it is getting throttled. So our upload is complete, and you can see we have entries with downtown as our partition key. And also Cosmos DB was able to recognize our geo coordinate because we had those coordinates as type point, and Cosmos was able to recognize that and save it. Let's go back and upload our second file for Fairview. So you can always modify your throughput settings for your collection. If you see there's a lot of throttling happening, you can increase it a little bit or decrease it. You can also set it to auto scaling, and Cosmos will take care of auto scaling your required throughput based on the traffic it's getting. So you can just click here and set your maximum RUs here. But I want to keep our budget in check. That's why I'm using manual throughput settings here. Let's upload the third one quickly. Now you can also query your total count in your collection. So if you keep on executing it, you will see that more and more data is getting uploaded. If you want, you can also query your Cosmos collection by your partition key, which is geo local area. And if I want to see the downtown count, you can see we have 1845 for downtown. If I want to check it for Fairview, we can do it this way. Now by default, your Cosmos DB will index all the fields, all the attributes that you have in your item, but you can always include or exclude path if you want. But this will need re-indexing of the whole Cosmos DB. So let's say if you have a very large set of data with millions of items, it makes sense to just index a path that you want to query later on in your application and take out the path that are not queried in your application. This will save a lot of RUs, save a lot of throughput cost for your application, and also your storage for index will be less utilized. For our cognitive search indexing purposes, we have our data here, and if I want to count the number of items we have here, I can simply run count1 query, and we have about 9,231 items. Now we are going to index this into our search service. So our source is ready. In the next section, we will create a search service and start building its component.